As we have seen what is rotational flow and irrotational flow, and along with that we have seen what is mathematical equation for rotational as well as irrotational flow. Let us solve a few practical problems related to these kind of flow. So we have a problem over here. The velocity component in two dimensions are u is equals to y cube by 3 plus 2x minus x square y, and v, that is velocity along y direction, is xy square minus 2y minus x cube by 3. So we have to show that it represents a case of irrotational flow. So there are two things over here, that is irrotational flow, irrotational and flow. Okay, so first we'll see that whether it flows or not. So whether a fluid is flowing or not, we can see that by applying continuity equation. Now since this is in two dimensions, we'll apply continuity equation in two dimensions. So what is given to you over here, that is u equals to y cube by 3 plus 2x minus x square y, and v equals to, that is xy square minus 2y minus x cube by 3. So we have to apply what is continuity equation. So what is continuity equation? Your continuity equation says that dou u by dou x plus dou v by dou y, that is equals to 0. So let us prove if it is equals to 0, then this entire fluid flows from one part to another part. So let us differentiate u with respect to x and v with respect to y. So dou u by dou x, dou u by dou x is equals to dou by dou x of y cube by 3 plus 2x minus x square y. So if you will differentiate this, first part will be 0, this part differentiation will be 2, and the second part will be 2x. So this will give us, that is 2 minus 2xy. Similarly, we have to differentiate the next term, that is v with respect to y. So that is dou by dou y of v, that is equals to dou by dou y of xy square minus 2y minus x cube by 3. So if you differentiate, so what do we get this part as? Dou by dou y of this part will give you 2xy, that is positive 2xy, and this will give you minus 2, and this part will actually tend to 0 because we are differentiating with respect to y and x is a constant for that part. So now let us see what is addition of these two, that is dou u by dou x plus dou v by dou y is equals to 2 minus 2xy plus 2xy minus 2. So now you can see this all terms will go away and your this entire equation is equals to 0. Now this means that whatever we have the equations of velocity, which are functions of x and y, both will contribute to the flow of the fluid. That means it is a case of fluid flow. Now we are sure that the flow is the flow of the fluid. Now we are sure that the fluid is going to flow. Now what kind of flow is that, we don't know. We have to check whether this case is for irrotational or rotation. So now over here we can see that u is a function of x comma y, and v is also a function of x comma y. So to have these two variables, that is in two dimension, it can rotate along z axis only. So now let us calculate this part, that is omega z. Now what is omega z equals to? Omega z equals to half of, that is dou u by dou y minus dou v by dou x, or rather we can also write this omega as omega x I cap plus omega y j cap plus omega z k cap, and that is equals to a determinant of, that is I j k. Here you will have u, v, w. Here you will have dou by dou x, dou by dou y, as well as dou by dou z. Now you can see, since the velocity component along z direction is 0, then what you will get is only omega z. Omega z. Since the velocity component is 0, you will have omega x will be 0, omega y will be also 0. So you can calculate the determinant by covering this two, that is dou u by dou y minus dou v by dou x. So let us calculate, and this entire determinant will be multiplied by half. So let us calculate what is dou by dou y of u, which is equals to dou by dou y. The equation is, that is y cube by 3 minus plus 2x minus x square y. So if you differentiate with respect to y, what do we get over here? Is the differentiation over here is 3y square by 3 minus of, this will be x square. So this will be equals to, that is y square minus x square. So we have found out what is the first term over here, that is dou u by dou y. Now let us calculate the second term, that is dou v by dou x. That is dou v by dou x. So let us calculate this dou by dou x of that entire term, that is v term. Now v, which is given to you as xy square minus 2y minus x cube by 3. So if we will differentiate this part, this will come out to be, this is y square, this will tend to 0, and this part will be minus of 3 into x square by 3. So this is y square minus x square. So now your dou u by dou x, dou v by dou x is equals to y square minus x square, and dou by dou y of u is equals to, from the previous part, y square minus x square. And what is omega z equals to? That is 1 upon 2 dou by dou x of v, or minus dou u by dou y. So either how, this will tend to 0 if you subtract this part. So now if this part is 0, if this part is 0, you know that the flow is called as an irrotational flow. Irrotational flow. So now we have seen whether the flow, so we have got this as omega z equals to 0, which means it is an irrotational flow. So we, in this problem, we have seen whether the fluid will be flowing or not. That will be confirmed by continuity equation. And whether the flow is rotational or irrotational flow, that will be confirmed by equation, that is for omega z, omega x, as well as omega y. So I hope you have understood what is I hope you have understood how to solve problems on rotational flow and irrotational flow. Thank you.